Hi there, guys. So today what we're going to be looking at are 4 different scenarios of how can we write equations of lines. So we would love for it always to be just pretty straightforward, and you've been given the slope, you've been given the y-intercept, hot diggity dog, we can write the equation of the line. However, in some instances, we are not going to be able to as easily write the equation of the line because the information that we've been given isn't quite as straightforward. So today we're going to look at 4 different scenarios, and in each one of those scenarios, how do you write the equation of the line? Okay, so for some of you guys, we have covered parts of this in class prior to this video. If we have covered the piece of the information that I am going over, if you'd like to watch for some extra review, I think that would be a great idea. However, if you would also like to fast forward a little bit all the way through until you get to a point that we have not covered, then you can do that as well. But the review is definitely not going to hurt you guys. So when we're looking at that first scenario that I've given you, how do you write the equation of a line if you've been given the slope and its y-intercept? So the first step is you should be able to recognize that your slope has been given to you as a value of -5. Its y-intercept is 2. And so hopefully you could see, okay, y is equal to mx plus b. I know that it's going to fit into that y is equal to mx plus b format because it has a slope of something other than undefined or a 0 slope. So what I mean by that is if a line or an equation has a slope of 0, then its equation is going to look a little bit different. Meaning that let's say that I had a line that looked like this. All right, and let's say that it was going through a y-intercept of 2, and it had a 0 slope in this case. And any lines that have a 0 slope are always going to have a y is equal to equation, meaning that it's going to say y is equal to 2. Now you might be asking yourself, why is it y is equal to 2? So if you go through and you choose any of these coordinates, you might be able to see that, oh, okay, well, that's the point, -1, 2. If I were to choose another point over here, we could see that that's the equation or the coordinate 5, 2. Or if I were to choose another coordinate over here, that'd be 1, 2, 3, 4, 5, 6, right? And so that'd be the coordinate 6, 2. And so if you notice on each one of those, the y part of the coordinate is always equal to a value of 2. The same thing if I were to go here and let's say that I were to draw another line that was going through down here. That would be the equation y is equal to -4. And the reason why it would be y is equal to -4 is because if I were to choose any of those coordinates, it would be -1, -4. Or that would, if I were to choose this coordinate right here, that would be the point 4, -4. It doesn't matter what coordinate I choose along that line, it's always going to have a y coordinate of -4. So that would be the coordinate -6, -4. And so that would be the line y is equal to -4. So that's how you would write the equation of the lines if it had a 0 slope. Now, if it has a slope that is undefined, then it's also going to have a different type of equation. So for example, here's all of my ones with a 0 slope. But if it's an undefined slope, then that means that it's going to be a horizontal line. And so for example, let's say if I were to draw a line that was going just like this. If I were to choose any of those coordinates, it would look like the 2, 1, or this might look like 2, 1, 2, 3, that would look like 2, 4, or this would be the coordinate 2, 6, or this would be the point 2, -3. And so hopefully you notice that in this case, if it's an undefined line, the x value is what's always the same. So in this case, this would be the line x is equal to a value of 2 because your x coordinate is always equal to 2. Same thing if I were to draw a line all the way over here, and that's at the x coordinate 1, 2, 3, 4, 5, 6. And so this would be the line x is equal to -6, because if I were to sit there and go through and list out all of the coordinates, its x coordinate would always be a value of -6. So that's how you would write the equations if the slope is a 0 slope or the slope is undefined. But in all other cases, other than those 2 situations, the way that you're going to write the equation, if it's a line and it's something that's linear, then it's going to fit into that y is equal to mx plus b format. Okay, so we can fill in or substitute the pieces that we know, and we would know y is equal to -5x plus 2. And so all you're doing is you're filling in the pieces of the puzzle that you know. Example number 2, the slope would be a value of negative 1/2 x, and the y-intercept there is a value of negative 2. All right, looking at example number 3. So here we know that the slope is 0, and it says its y-intercept is 3. So hopefully you should be able to say, okay, well, if it's got a slope of 0 and its y-intercept is up at 3, then that means that that line looks something like this. And if you were to sit there and look at all of the coordinates that fall along that line, it would be that your y-coordinate is always equal to 3. So we would say that the equation of that line is y is equal to 3. Example number 4, its slope is 1/3, but its y-intercept is 0. So we could just write that as y is equal to 1/3 x plus 0. But the more accurate way of writing it would just be y is equal to 1/3 x, because that plus 0 just means that it's going through the origin. All right. So if we're going to write all of those equations of their lines, that's what each one of examples number 1 through 4 would look like. All right, scenario number 2. So how do we write an equation of a line if we've been given a graph? Okay, so hopefully we're starting to get a little bit better at this. And so the first step is again, if it is a diagonal line, meaning that it's not vertical, it's not horizontal, then it's going to fit into that y is equal to mx plus b format. And so in that case, we're just filling in the pieces that we don't know. All right, so we need to figure out what is our slope first off. So first, our slope, we could figure that out by finding some good fit points. And so it looks like here's a couple of good fit points that are kind of crossing through these areas. I need to figure out moving left to right. What is my change in y over my change in x? Meaning how far up do I go and how far right left or right do I go? So moving from that y-intercept, I'm going up 1, 2, 3, 4. So I went up 4 and I'm going to the right 5. And so in that case, you should be able to say I went up 4 and to the right 5. So my slope is 4/5. Y is equal to 4/5 x. And then my y-intercept was a value of 2 because that's where it was crossing the y-axis. All right, looking at example number 6. So my slope, so again, I'm going to try and figure out where are my good fit points first off. And here are my good fit points that are kind of along that line. And looking at those good fit points, it looks like I'm going up 2 and to the right 3 every single time. Up 2 and to the right 3. Or you could also say I'm going down 2 and to the left 3, which is the same thing as going up 2 and to the right 3. So your slope, which is represented by your change in y divided by your change in x, means that you're going up 2 and to the right 3. So your slope is 2/3. And so the equation of that line would be y is equal to 2/3 x minus 2, because your y-intercept is down here at a negative 2. All right, looking at example 7. So when you look at example 7, the equation of that line is going to be, it's going to fit into that y is equal to mx plus b format because it's not horizontal, it's not vertical, it's just a diagonal line. So trying to figure out my good fit points, it looks like here are my good fit points. Here's another one up here. And so it looks like if you're trying to figure out moving from one point to the next, what do? It looks like we are going down a total of 1, 2, 3, and to the right 1. So down 3 and to the right 1. And so this is one of those scenarios where our slope is going to be represented by a negative value. Down 3 and to the right 1. So your change in y divided by your change in x is down 3 to the right 1, or a slope of negative 3. So your equation of that line would be y is equal to negative 3x plus a value of 2, because our y-intercept is up here at a positive 2. All right, so I'm going to go ahead and move on to example 8. So example 8, the difference with this one is that it's going through the origin. All right, the only thing that's going to change is that our y-intercept is now reflected by a value of 0. So I'm still going to figure out what my slope is. So my slope, it looks like I'm going up a total of 4 and to the right 2, up 4 and to the right 2. Or you can also see that there's some intermittent points there that I could also go up 2 and to the right 1. And hopefully you're saying, oh, well, going up 4 and to the right 2 is the exact same thing as going up 2 and to the left 1, because those are equivalent fractions or equivalent ratios. So looks like our slope is 4/2 or 2/1. And so we could say the equation of that line is y is equal to 2x plus 0, because it's going through the origin. But the more accurate way of writing it would just be y is equal to 2x. All right, so I'm going to go ahead and box all of the equations as they should be for each one of those lines, and we're going to move on to example number 9. So hopefully for example number 9, you're thinking, or hopefully you're thinking, that, okay, well, that's a horizontal line, so that means that its equation is going to look a little bit different. And anytime you get tripped up or you're like, oh, I can't remember if it's x is equal to or y is equal to, I would suggest you go through and say, okay, well, what's that coordinate? Well, that coordinate right there is the coordinate 2, 3. And let's choose another one. And there's the coordinate -5, 3. And let's choose another one. And there's the coordinate 6, 3. And hopefully, once you've chosen some of the coordinates that fall along that line, you can see that there's a pattern that the y value in that case, meaning when you look at the coordinate, the y value is always equal to 3, which would mean that the equation of that line would be y is equal to 3. All right, let's look at the next one, example number 10. So hopefully you're looking at 10 and you're thinking, okay, that's a vertical line. So that means that its equation is going to be something other than that slope-intercept form, that y is equal to mx plus b. And if you're trying to figure out whether or not it's an x is equal to or y is equal to, go ahead and say, okay, well, that's the coordinate -5, 5. Okay, well, that's the coordinate -5, 1. This is the coordinate -5, 5. And hopefully in this case, if you continue to look at coordinate after coordinate, you can see that the x in this case, that the x value in each one of those coordinates is always equal to a value of -5. So the equation of that line would be x is equal to -5. All right, our last two examples for these two scenarios. All right, so example number 11. So really similar to the ones that we've looked at, you know that it's going to fit into that slope-intercept form because it's a diagonal line. It's not horizontal or vertical. So I'm going to say, okay, well, I know it's going to fit into y is equal to mx plus b. I just need to figure out what my slope and my y-intercept are. All right, so it looks like my y-intercept is down here at a value of -3. I'm going to go through and try and find some good fit points. It looks like I've got some good fit points going up 2 into the right 1, up 2 into the right 1. So my change in y divided by my change in x means I'm going up 2 into the right 1. So that means my slope is 2. So y is equal to 2x, and then my y-intercept is a -3. So the equation of that line would be y is equal to 2x minus 3. All right, example number 12. All right, so this is going to have a negative slope because hopefully you're going to see that it's decreasing if you're reading it from left to right. Here's my y-intercept at a +3. And I'm going to go through and highlight all of my good fit points like we've been doing. And it looks like for this that my slope is going down 3 and to the right 2. So that means that my change in y divided by my change in x means I'm going down 3 to the right 2. So my slope is -3/2. So y is equal to -3/2 x plus a value of 3 because up here it's crossing at my y-intercept of 3. All right. So those are your first two scenarios. All right, so the scenarios on the back. All right. So the next two scenarios that we're going to look at are how do you write the equation of the line if you've been given slope and 1 point. All right, so if you've been given slope and 1 point.